Alright, 19.4, perpendicular lines. We're going to start talking about perpendicular bisector. Thing is, there's one thing you have to learn for this section, and you have to remember the Pythagorean theorem. But this is the one thing you got to learn, is what the heck is this theorem and what does it mean? So it's not too complex, you just kind of have to get a good grasp of it. So what we're going to start with is just go ahead and draw this line segment AB down on your paper. So probably right hand side is fine. So draw line segment AB. Okay. What you're going to do with this line segment is you're going to draw in a bisector. Okay, remember a bisector is something that cuts this line segment into two equal parts. So basically cuts it in half. So right here, I'm going to call this our bisector, right? C is our bisector. But if you notice, we're talking about a perpendicular bisector. So we got the bisector part. We need to figure out what the perpendicular means. So perpendicular means a 90-degree angle, right? Means intersects it at a 90-degree angle. So what we're going to do is we're going to draw a line through this line segment that crosses through the bisector and makes a 90-degree angle with that line segment. Okay? And this theorem, I'm going to read it. It's got a lot of complex words, right? It's a lot of words put together, but it's not too bad. If a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of the segment. For instance, if I put this point D right here, the distance from A to D is the same as the distance from D to B. Those are equal distances. If I put a point right here on this line, it is called E. They have an equal distance to B and an equal distance to A. I could put the points anywhere I wanted them to. I could put one way up here, and they have an equal distance to the end points, okay, no matter where the point is on this line. So that's one thing that you got to learn, right? One thing you got to understand about this theorem, and then we need to know how to apply it and how to use the Pythagorean theorem in this process. So let's look at the diagram. I'm going to erase this. If you still need it, just pause the video. Okay, so we've got segment A, C. Okay, we're going to use a bisector, which is going to be called E. And then we're actually going to draw a line segment through here called, so we're drawing a line segment through D and B. Okay, this is a perpendicular bisector because it is perpendicular and crosses through the bisector. Alright, and it says, one of the questions is, we could draw these lines in, right? We can imagine them or draw them in. Let's see. So question 1. We know that ED is 16. DA is 20. We are supposed to find DC. Okay, so let's go ahead and draw that in. We know that ED is 16. We know that DA is 20. And we're supposed to find DC. Well, remember that any point that lies on this perpendicular bisector is going to be equal distance from the endpoints. So we should automatically be able to say that DC is 20. Okay. Alright, and then let's try another one for number 2. If EC is 15, BA is 25, We need to find BC. Okay, I'm going to let you do that one on your own. So EC, I will draw it in, right, to help us kind of visualize, but I want you to solve it on your own. EC is 15. BA is 25. And we're finding BC right here. Okay, so that's what we're trying to figure out, what that length is. Okay, awesome. You're doing that one on your own. Cool. So let's make it a little bit more challenging. Alright, let's erase this. Let's erase all of this. Let's just start over. Beautiful. Okay, so here's a drawing. Alright, we have A, B, C, D as our points. C, D. Okay, and we know that these are equal distance. Cool. So it tells us a couple things. It tells us that AD is equal to 10 inches. It tells us that BD is 6. And it asks us to find AC. So if I draw that in, AD is 10, BD is 6, and it wants us to find this whole length down here. Well, one thing we should be able to automatically add in is we notice that this side is the same as this side. The way I know that is because in the drawing it has these little dashes which indicate that they are the same length. So we can also have a 10 there. And the thing that I'm going to look at is right here we have a right triangle. And what that means, whenever you have a right triangle, meaning a triangle with a 90-degree angle, means that you can use this Pythagorean theorem. And you just need to know where the A, the B, and the C go. So your A and B are your legs. Right, we've talked about this before, the legs. And your C is your hypotenuse. So your A and your B are going to be the length of this down here, and the length of this right here. Your legs that make up your 90-degree angle. And your C is going to be this hypotenuse here. Okay, so when we plug in the lengths that we know, here's what we have. We have a 6 that can go in right here for the A. We don't know what B is, and our C is a 10. Okay? And then we're just going to solve it. 6 squared is 36. 10 squared is 100. And we're going to keep solving. We're going to subtract 36. Okay? We get B squared is equal to 64. To get rid of that square, as we've talked about before, we do have to square root. And we get B is equal to 8. So what that means is the length of this is 8. Because this point right here was a bisector, that means this point was a bisector, that this side and this side are congruent or equal, which means that this is also a length of 8, which means that the total length right here, what it asks us for, would have an answer of 16. So that got a little bit more complex than the first one, but I don't think it was too terrible. Okay, so I'm going to give you a couple example problems, make sure you can work through them, and then you'll be done with 19.4. Alright. So, A, F, G, H. So So let's say we know AF is equal to 17, FH is equal to 12, AH is equal to 10, and we want you to find FG and HG. Perfect. Okay, go ahead and do that one on the left-hand side as I'm writing the other one that I'm going to have you do on the left-hand side. Okay, so this last one here, you're given a segment with a perpendicular bisector. So notice that it's perpendicular because there's that 90-degree angle, and it is a bisector because both sides of it are congruent. And you're given a couple lengths of a couple legs. So HI is 15, LI is 12, and you're trying to find what is, nope, just kidding, that's not what I want you to find. I want you to find HL. Okay, the length of HL. Alright, go ahead and do those two on the left-hand side. Once you are finished with those, you are finished with 19.4.